Hello, good evening all. Hello, I'm audible. Please just confirm. Anyone, please, whether I'm audible or not. Okay, fine. So actually, I have recorded the week one. So because that time actually in IT, I'm from IT Guwahati. So that time the network issue was happening. So now the network is fine. So I here we'll solve the three set of questions. First from your 2025, then 2024, 2023. The same hydraulic engineering course, assignment two. So let us move with question number one. So question one is, hope question is visible, please, everyone. Anyone can confirm. Yes, you can write in the chat box also. Psychath already, okay. Okay, Shreya is telling, okay, fine. So now let us move. In steady flow of a compressible fluid through a pipe, the density area and the velocity at a particular section are 1.5 kg per meter cube, 0.5 meter square, and 3 meter per second. So here three data is given respectively. At another section, the density and area are, here it is given 1.5 and 1 meter square respectively. What is the velocity at that section? So please just you try to solve. You have 2-3 minutes, then after I'll solve. So please just try to solve. Okay. So now I have connected my pen. So pen is visible to all of you. Pen is visible. Option A 1.5, option B 3, and option C 4.5 meter per second, and option D 6 meter per second. So you have two pipe. Not you have one pipe and you have two sections. And remember, please, here is a compressible fluid. So we have discussed a lot about the compressible and incompressible fluid in your first week. So hope you remember. So now and steady flow. Here remember one thing. These are the very fluid mechanics stuff, very important fluid mechanics stuff. So here you can see 0.5 at first section and second section is 1. So if you draw like that, here maybe the area will be 1 and here area will be the 0.5 meter square. This is your first section, remember. This is your second section. So data is given 0.5 area, density 1.5 kg per meter cube, and your velocity is given rho 1, v1 and a1 I'll write here. And this is your 3 meter per second. Here your density is given 1.5 kg per meter cube and area is given 1 meter square. You have to calculate V2. So here your density is similar. Remember this. Density is similar. The fluid is compressible, but in the question density is given similar. Okay, no issue. We have to solve. Maybe the slightly variation in the density. That's why it is given the more or less same at both. Even though fluid is compressible. You can write your answer in the chat box. Okay, I have opened the chat box. Anyone, please. Okay, A. Indra is telling A. Okay. Ghosh is telling A. Okay. Both are telling A. Other friend, please also try to solve. Actually, these classes are designed for you have your practice. So you have to practice, please, not the theory classes. So, anyways, sir is taking the theory classes and some numericals also. But here you have to solve the questions. That will be a benefit for you. Similar question you can expect in your coming assignments. Also, you can expect in your final NPTEL exam and other competitive exam also. So everyone able to access the Excel sheet because these whatever I'm recording today and previous day I was recorded, I'll upload in the YouTube and that link I'll provide in the Excel sheet which is provided by NPTEL. So if you are able to that Excel sheet, you are able to access the video or also the whatever I'm teaching here, the assignment one, assignment two, and assignment three. That things also you can you are able to access because I have created one folder, Google Drive folder, and I have given the access to all of you, or anyone can access, not you only. So if you are not able to, please just inform me. So I'll just show you where you will find out that Excel sheet. Okay. Or in the last, I will show you. Maybe some student not able to find. So I'll show. Okay. So three student telling option A. So let us move with the question. I'll show you first answer, which is very important because okay, option A is correct. 1.5 meter per second. Option A is correct. How? You know already the mass balance things. Mass enter here. Always remember this. In fluid mechanics, whatever uh, at your level, so mass in because here there is no loss. So always this formula will be fine. Mass enter at one section, mass will be out from another section. So this is a key concept. Sometimes what will happen here, maybe the sometimes you have some porous these things, some hole, and water will pass out from here. Maybe the M not. So that time your this equation will not valid. So remember, please, this is valid only. There is no loss. Anyhow, in the question, it is not written, but you have to remember. If nothing, anything, if in the question, if not discuss about these things, losses, friction losses, and all, you have to consider these things only, mass in and mass out. Okay, mass in and mass out will be the always fine, but in case of friction and all, the energy will be the different because some energy will be losses by your friction of the pipe and all. So here we'll discuss about the mass. So formula you know already. Rho A V, rho 1 A1 V1 is equal to rho 2 A2 V2. So from here you can very easily calculate 1.5 into A 0.5, velocity 3 is equal to 1.5, A is 1 and V2 you have to. Very simple. No need calculator here. So, okay. So your V2 is equal to 1.5 meter per second. Very easy. Okay, now let us move on the next question. Question number 2. Okay, so here answer is visible, no issue. We have to read. The total acceleration has the same value as, okay, this is very, very important question, please. Total acceleration has the same value as convective acceleration in the case of unsteady flow, whether it is true and false. So it is false. How? How it is false? Anyone can write in the chat box? Or first you have to write total acceleration means what is? Anyone can write. I'm waiting in the chat box. I'm looking. Anyone can write. Please just remember, this is not our exam hall. So you have to remember. If you not know, you can Google, you can use Chat GPT, whatever. Because this is your not class, you have to here solve the questions anyhow. So what is the total acceleration? Even though nowadays the AI is very, very important in your study. So if you will use effectively, if you know, not believe any time on AI, but you can understand the very well things using AI. It's depend on you, please. So what is the meaning of total acceleration? So we are discussing about the fluid mechanics. So please, uh, yes, anyone tell what is total acceleration? Whether it is one thing here, it is written. The total acceleration has the same value as convective acceleration in the case of unsteady flow. So the question is indicating you have two type of acceleration. Is the combining of two is known as the total acceleration. So one is convective. What is another one? Anyone can write? Very important. Okay, no issue. I'll tell you this. Okay, please wait. So your total acceleration is local acceleration plus convective acceleration. This is already here written. Okay. So what is the equation? If I want to write acceleration in the x direction, acceleration in y direction, acceleration in z direction. So you have actually in the fluid mechanics, in solid mechanics, you have acceleration most of the cases one direction. Sometimes you're circular, uh, but here you have the three type of actually the three-dimensional acceleration. So let us write in the x direction ax, and if we consider the x direction velocity, X direction velocity is u, y direction velocity v, and w direction velocity, that is z direction velocity is, okay, z direction velocity is w. So you have to write, if I am talking about the x direction, so you will write in terms of u, del u by del x, del u by del t. So this is your local acceleration. Now u del u by del x plus v del u by del y plus w del u by del z. So this is the equation. Similarly, you can write in the y direction also. So I'll write here in the y direction, just for you how you will write. So in case of y, because in the y direction you have considered velocity v. So del v by del t. Here remember please. And here your del u, this will be the u, but this will be the del v by del x plus v del v by del y plus w del v by del z. This is the equation. Similarly, you can write for the z direction also. Now, so this acceleration depend on your flow whether it's steady or unsteady. This depend on the two cases, steady flow or unsteady flow. Steady flow or unsteady flow. So steady flow is when your change in flow parameter, let us assume the velocity is equal to 0. Unsteady flow not equal to 0. Del u by del t does not equal to 0. So here your case is in case of unsteady. So total acceleration is combined of these two. This total acceleration is equal to your local plus convective. In case of steady flow, this will be 0. So your total acceleration, convective acceleration will be equal when your flow is steady. But in case of unsteady flow, this will not equal to 0. So that's why option your false. Because total acceleration in case of this unsteady flow is equal to local acceleration and convective acceleration, not only equal to the convective acceleration. So hope you all understand. So if anyone have any doubt, you can ask, please. If you understand, you can write yes in the chat box. So I'll move on the next question. Please. Please just write yes. Okay. Anyone have any doubt, please? You can write in the chat box yes. If you will not write, then how I'll understand whether you are able to understand or not. Because this class is designed for only your understanding, solving questions and all. Okay, anyway, let us move on the next question. We will not waste time because time is very, very important nowadays. Okay, next question is question number 3. According to Bernoulli equation, which option is correct? Whether A, B, C, D, which one is correct? according to Bernoulli. Okay, Kazin is telling option A. Okay, fine. Another student, please also try to solve which option is correct. Okay, Gopika is also telling A option. A means Z plus P by W plus V square by 2. See, here the question have a big mistake. Here is not definition of what is P, what is W, whether it is unit weight or whether it is weight and all. So this is the big mistake. So okay, no issue. Hope I think why it is written in this form. Maybe sir was taught you in these notations using these notations. So maybe without any description of your Z, P, rho, PW and okay, no issue. But you have to remember when you will set the questions for a student. So remember please, such type of mistake you have to remember during your formation of questions and okay. So any two student telling A option, so maybe A option will be correct according to Bernoulli. So Z Z here is your potential. Okay. So P by rho Z and V square by 2Z plus Z. So anyone can tell what is your P by rho Z? And rho Z here in terms of your question P by small p by your W. Z you know already. This is unit of meter, unit of length actually. Okay. So what is P by rho Z? V square by 2Z and Z. And P here is pressure, rho is density, G is you know already, V is velocity, and Z is your, I'll tell you, Z is your datum height. So one I have already told you. This is your datum height. Now, and what about V square by 2Z? Because all these have the unit of meter. So you have to write this, the name of these combined P by rho Z in terms of head. This is your datum head. So this is your, if P is there, so pressure head. And this is your, if V square is there, so what will be the V square by 2C? I want to hear from your side. Kinematic head. Okay, good, fine. Yes, it is your kinematic. Okay, so yes, option A is correct here. So now let us move on. Remember, it is equal to the this Z plus P by W plus V square by 2 is equal to constant. Remember this. Means if you have one pipe like that, and here energy E1, here energy E2, this will be the equal E1 plus E2 if no loss. Remember, please. If no loss, remember. Okay. So now let us move on the next question. Question number 4, very important. The velocity component U is equal to lambda x y cube minus x square y. V is equal to x y square minus 3 by 4 y to the power 4. Then the value of lambda for possible flow field involving steady incompressible flow. So you have to understand the statement. Then you have to tell the value of the lambda. Anyone, please. Just try to solve. Anyone, please just try to solve. Very important question. Once here you will solve, then you will be always remember such type of questions. Condition here is given, then the value of lambda for possible flow field involving steady incompressible flow. Very important. Flow is possible and condition is also given, the steady incompressible. So just I'll give you hint. The hope you know about the continuity equation. So if flow is possible, then this velocity component should follow your continuity equation. Means del u by del x plus del v by del y is equal to 0. So once you will differentiate and put the value and calculate what after the differentiation, you will find out easily the lambda value. Okay, total 12 students joined. So please, you have to solve this question. You have joined here, it means you are interested. And if you are interested, you don't waste your time, please. Anyway, I'm recording the video. So if you have not interest, so there is no meaning you have to wait and see the classes. Just practical. Be practical, please. Whatever you are getting, please just write. Okay, so let me just show you. Okay, so option will be your 3. That is option C will be correct. And how it is correct? The equation, the solution here it is given. Same the continuity equation. Whatever I was telling. Because here will not take the W1 because of the W component of the velocity is not given. So this equation is written for a 3-dimensional. So but here we have the 2-dimensional flow. So del x, del u by del x plus del v by del y is equal to 0. So del u by del x. So here you have to write lambda x square y cube minus x square y plus del by del y x y square minus 3 by 4 y to the power 4 equal to 0. Now you can very easily differentiate. So here lambda y cube minus 2xy plus 2xy minus, sorry, minus 3 by 4 4y cube is equal to 0. So now you can easily lambda y minus 2xy plus 2xy minus 3y cube is equal to 0. So this will be the 0, these two combination, and your final will be lambda y cube minus 3y square. So from here you can write 3y square, and from here I'll write here your lambda is equal to not 3y square, here it is cube, so this is cube. Sorry for the mistake. So this will be the cube. So lambda is equal to 3 y cube by y cube. So this will be your correct answer. Option C. So hope you understand. So anyone can ask if you have any doubt in this question. I'm waiting in the chat box. Anyone have any doubt? You can ask the question as much as that is easy question, and whatever you are not able to understand, you can ask. Okay, so hope you all understand. So now let us move on the next one. Next question. Question number 5. The concept of stream function. The concept of stream function, which is based on the principle of continuity, is applicable to irrotational flow, two-dimensional flow only, three-dimensional flow, and uniform flow only. The concept of stream function, remember please. The concept of stream function, which is based on the principle of continuity. These two terms is very important. Is applicable for rotational flow only, two-dimensional flow only, three-dimensional flow only, uniform flow only. So first you think, if you are not able to solve yourself, then you can use Google, no issue. But you have to first think. Please everyone try to solve and write your answer in the chat box. Option B, okay? Gopika is telling option B. Again is telling option B. Okay, fine. Other is also okay. Okay, fine. Sujal also telling option B. Means two-dimensional only. Okay, fine. Other student is also can attempt. Okay, no issue. So we'll move on the next question. So I'll show you just answer two-dimensional flow. Why? The detailed solution here also written very well. So let us read. The stream function, detailed solution. The stream function defined only for two-dimensional flow. Remember, please, defined only for two-dimensional flow, which is steady, incompressible. The stream function defines, not defined, the stream function defines only for two-dimensional flow, which is steady and incompressible. The properties of stream function, if psi exists, psi here is your stream function. Remember this. Stream function. Stream function. If psi exists, it follow continuity equation and the follow may be rotational, irrotational. If psi satisfy the Laplace equation, then it follow the irrotational. So very important line. So you have to remember. Okay. Next question. So question is question number 6. Which method is most commonly used in the fluid mechanics for analysis? Lagrangian method, Eulerian method, control volume analysis, none of the above. So here I'll give you some concept also about what is Lagrangian, what is Eulerian approach, what is control volume analysis. In very simple term, I'll try to uh, explain you in very simple term. First, you have to attempt. Okay, Hagen is telling option B means you are telling option that is Eulerian method. Okay, Kopika also telling option B Eulerian. If possible, please all students try to participate. If your answer will be wrong, there is no meaning because this is not your exam, please. Already I have told you. If anyone have wrong answer, there is no meaning here. So don't worry about the your wrong answer and right answer. If you not know, I have already told you, you can Google it. That will be beneficial for you. Okay. So anyone please? Only okay. Anjana, Monica, and Sujal also. Okay, fine. Okay, fine. Good attempt. So Eulerian methods. Okay. Here control volume analysis is also given, please. So you have to understand what is control volume analysis. So let me just explain you what is Lagrangian approach. I'll explain in very simple word. So if this is a river, you are looking from the top and you have some instrument for your velocity measurement. Okay. So once you will put here the instrument, let us suppose you have put here the instrument, and as water is flowing, this instrument is floating with your water. Means the condition here, whatever, let us suppose the lot of millions of the fluid particle in this river system. So this instrument, let us assume particle 1, particle 2, particle 3, particle 4, 5, 6, 7, lot of. So your instrument is capturing velocity for instrument or for your particle number 5, let us assume, particle number 10, let us say, particle number 10. So here also the same particle move in the downstream. This is your upstream. So the same particle, here also the same particle, here also the same particle. Means the particle identity not changes in a Lagrangian approach. Remember please, if your instrument measuring here the velocity of particle number 10, so it is measuring velocity here also 10, here also 10, not 11. If 11, this the Lagrangian approach will be wrong. So particle identity should be same. Particle identity means whatever the particle, let us suppose here 10, I have given the name, the digit. So the 10 should be everywhere throughout. So this is your Lagrangian approach. What is Eulerian approach? Eulerian approach, this is your river, same river, the upstream, and this is your downstream. So you will take a section, and in the section you will measure the velocity. Let us suppose here the 1, 2, 3, 4, 5, 6, 7, 8, lot of millions of the particle is there. So at one time, at 1 second, you have measured the particle number 2. Let us suppose here is 10, 20, 10 and here 20. First, you will measure the speed of 20. Then in the same place, you are not changing the place. Here, your place is changing time by time. Then you are measuring for 10, you are measuring for 4, you are measuring for 2. So like that. This is Eulerian approach. So a fixed volume, fixed space. So sometimes you can say the control volume approach also, Eulerian approach. So remember please. But here if Eulerian is written, so you will go with Eulerian. Remember. Here it is, you can see the detailed solution. In Eulerian method, we describe velocity, acceleration, pressure, etc. at a point in the flow field. Hence, at a point, remember this. At a point means fixed location. Is also most commonly used in the fluid mechanics. Mostly used, not always. So you have to understand, try to understand the meaning of word. Here is most commonly, not always written. So remember. Next question. So hope you all able to understand Eulerian and the Lagrangian approach. Now the next question is, which of the following is correct? Path line of two particles in an one-dimensional flow can never intersect. Path line of two particles in an one-dimensional flow can never intersect if the two flow particles move along the same direction. Next, the path line of two particles in one-dimensional flow can intersect only if the two particles move along the same direction. Option D, the path lines actually, not lines, the path lines of two particles in one-dimensional flow cannot intersect if the two particles move along different directions. So you have to read the question very carefully. Here, please. You have to read very carefully. The question is about the path line. First, you try to attempt yourself. If you are not able to solve, then you can use Google. After this question, I'll take the 5 minute break, please. You can also take for your tea and coffee, whatever you want. After that, we'll solve another set of questions. So actually, I will upload the all three set. Let us suppose here, if I have completed the only three set, or only two or one set. So anyway, I'll upload the all three set, 2025, 4, and 23. You can go through, and if anyone have any doubt, you can ask, please, in the next class. Whatever I'll upload the three. So maybe you have some doubt. Anyway, solution will be there in the whatever I'll upload. Okay. Gopika is telling option A. Okay. Anjana is telling A. Okay, fine. Monica is also telling A option. Fine. A option. All three students telling A option. It means maybe the A option will be correct. Khagen is telling option B. Okay, fine. So let us see whether A option and B option will be correct. Path line of two particles in one dimensional flow can never intersect. This is the path line. Not we are talking about here the streamline. Remember, please don't confuse. Option B, the path line of flow, path lines of two particles in one dimensional flow can never intersect if two particles move along the same direction. So these two options I have got it from your side. Okay, now I'll show you the answer. What will be the correct? Option B will be the correct, please. Okay. So the path lines, pen, yes. Let us see first the detailed solution. What is telling? The path line of a particle in one dimensional flow in a straight line along the direction it moves. The path line of the particle in one dimensional flow, 1D flow. 1D flow means one dimensional. It is moving only one direction, not the three direction X, Y, Z. What earlier I was telling in the, I think the question was about the acceleration. Here the question is one dimensional. Condition is given. Flow is a straight line along the direction. One dimensional flow is a straight line along the direction it moves. If two particles move along the same direction, their path line will be the parallel to each other and will never intersect. So here, path line of two particles in one dimensional flow can never intersect. Okay, little bit close, but most appropriate one. The path line of two particles in a one-dimensional flow can never intersect if two particles move along the same direction. So remember, please. Here, the condition is given the same direction. So you have to choose the most appropriate one. If this was not there, then option A you can also correct. But here the most appropriate one. You have to remember in the objective type question, you have to go with most appropriate. Okay. For continuity equations given by del vector and your v vector equal to 0 to be valid, where vector v is the velocity vector, which one of the following is necessary condition? Steady, rotational, inviscid, steady and incompressible. So if anyone, okay, please you have to try first. You have to try and think for the continuity equation given by. This continuity equation is given. So you have to understand first what is the meaning of the del operator, what it indicating. You might have asked in the question in your Viva of in the Viva in the fluid mechanics, bio external. So you have to know what is delta. Option D, okay, steady and incompressible. Kagan is telling. Okay, fine. Other student, please also try to attempt. All 13 here you have joined. So please you have to write your answer, please. You can Google also because here it is going on the self-evaluation. Whatever you know, whatever you don't know, is up to you. You are evaluating yourself. Okay. Monica is telling D option fine. Two student is telling option D. Other student please also can attempt. Okay, no one. Okay, I'll take it. Very simple concept of del operator. Actually, is a notation of combinedly this your del u by that is del by del x I del by del yz plus del by del zk. This is your del operator. Sorry. Now, what is your v vector? Vector v is ui plus vj plus wk. Once you will multiply these two things, you will get what? I will be the 1, but ij will be 0, ik will be the 0. Similarly with jj will be the 1 and another ji will be the 0. So hope you all know the vector calculus. So here del dot v vector is del u by del x. After multiplication, writing directly del v by del y plus del w by del z. If it is equal to 0, so you can write it. So this is your same continuity equation, and this equation was about already we have earlier solved the question. Flow was steady, that is change in time 0 and incompressible. Means rho is constant, density is constant. So hope you all understand. Now I'll show you one question, then I'll go for 5 minute break. Sorry, question number 9. So here explanation you have to also understand. This is your general continuity equation in terms of steady and for incompressible flow. Unsteady and incompressible flow. Both here, this equation. But you can write in this form also. Del for del you can write this del by del x, del by del y, del y. And rho v you have common. Now for steady and incompressible, this will be the 0, and incompressible your rho will be the constant. If this is 0, then del rho v vector. V will be also 0. Your this rho will be constant. So it is also 0. Constant means some value. 2, 3, something like that. 10, 100, 1000, whatever. Constant value. And so now you will get finally this. And this is representing your del V vector. Question 9. So you just read yourself. I'll take 5 minute break, then after I'll come. Okay, please. So, okay, question number nine. For question number nine, Kagan is telling option C. Okay, fine. And Monica is telling A. Anjana is telling C. Sujal also telling C. Gopika also telling C. The path taken by the smoke coming out of a chimney represent A. And in the bracket it is written in concentric circle, whether it is path line, streamline, streak line, or your stream tube, which option will be correct. So, okay, many students telling option C. Okay, I'll show you. Okay, so I'll just show you the direct answer. This is your straight line. Option C will be correct for this. And what is a straight line? So, in detailed solution will read path line is the path followed by a particle in motion, whereas a streamline is an imaginary line within the flow such that the tangent at any point on it indicate the velocity at that point. A stream tube is a collection of streamlines. Fine. A strict line is a curve which give an instantaneous picture of the location of the fluid particle which have passed through a given point. So in chimney, you just remember from this particular point. So that is the main things from a given point. Hence, the path taken by smoke coming out chimney in concentric circle in concentric circles will represent straight line. So hope you were able to understand. Very simple word read. Next question number 10. Which of the following is correct? There will be no flow across the stream tube. There will be no flow along the stream tube. There will be no flow both across the stream tube and along it. There will be flow both across the stream tube and along it. So please you just think on that and try to give your answer. Question number 10. Which of the following is correct? The question here is about the stream tube. And based on this stream tube, four option is given. Four option is given. Okay, A option. Shreya is telling A. Monica is also telling A, and Sujal also telling A. Okay, fine. Okay, let me just show you the answer. Okay, option A here is correct. There will be no flow across the stream tube. Detailed solution. The stream tube is a fluid mass bounded by a group of streamline, as we have already seen in the previous question. Since the movement of fluid mass can only be along the streamlines and never across them, there will be no flow across the stream tube. So, definition here, please you try to understand. Your stream tube is a collection of streamline and streamline never cross them. Okay, so next question, next set actually. This is your okay, next set. So next set is visible, please. Anyone can tell. Next set, you can write in the chat box. Okay, fine. So question first is question one. The atmospheric pressure at 103 kilonewton per meter square, water, 760 mm of mercury, all of this. Atmospheric pressure at sea level. So you have to check, please. So hope everything is visible. Okay, fine. So on my screen, actually, one comment is coming. The microphone is not working. Is it like that? Let me just reset. Okay. So you write your answer, please, again, because I have just the browse. Just refresh the this your YouTube link or this your Google link. Okay, D option, fine. All of these. Okay, fine. Nice. So atmospheric pressure at sea level is 103. Yes, it is fine because atmospheric pressure at sea level, this value in your Newton per meter square. Atmospheric pressure at sea level. So in kilonewton, when you will write, you can write 101.325 kilonewton per meter square. So it is 103.32 or 103, that is fine. So similarly, 10.3 meter of water means 101.325 is equal to rho g h. Water here it is telling. So 1010, I'll consider 10 here for G and H. 1325. So 40. This is your 10. So 10.13. So H is equal to 10.1325. So yes, it is also correct. 760 of mercury. Similarly, you can write 101.325 is equal to rho mercury Hc into G H. So this value is your 3 into 10 into H. So question is given in the mm. So when we will calculate H value, it will come 0.760 meter of mercury. But if it is given in mm, 760 of Hg. So all option is correct. Hope you understand. Question number 2. Very easy question. Same concept you have to use. The height of water column equivalent to a pressure of 0.2 megapascal is 15.38 meter, 20.38, 25.38, 30.38. So same question. Please just try to solve. I'm waiting. Okay. Monica is telling B option. Fine. Okay. Gopika is also telling B. Fine. Okay. Uh, Anjana actually telling option B. Okay. All three students telling B. So hope option B will be correct. Nothing here you have. Sorry. Today I'm very cold and fever also, so that's why I'm not able to feel energetic today. Okay, no issue. So now the pressure is 0.2 megapascal. So here you have to write in terms of water column. So similar thing here. This was the pressure. You have to write in terms of head also. You can write very easily. This is your water. So H is nothing. Here you have to write in terms of 0.2 into 10 raised to 6 Pascal, or you can say Newton per meter square. So H is equal to divided by 10 raised to 4. So approximately H is equal to 0.2. So H is equal to 20. So nearest one is your 20.38. If you will consider G value is 9.81, you will get the exact your this exact answer option. So next question, question number 3. Okay. So answer is visible, no issue. The liquid used in manometer should have low density, high density, low surface tension, and high surface tension. Answer is high density. Why? Anyone can tell? In the chat box you can write please. Why? You have to have the high density in the manometer. And what is the use of manometer? First, we just tell. These are the very standard question. The use of manometer and why we need to use the high density. This question actually is you may face in your Viva exam. Used to measure pressure. Okay, fine. Other student please also can attempt. Why manometers use high density and the use of manometer. Okay, one student Gopika is telling measure used to measure for your pressure measurement. Okay, nice attempt. Next question. Next student, please. Another student, please also try to write. Okay, clear reading. Okay, near about the exact answer, but not this is exact one. Okay, due to low vaporization. Okay, fine. Just think on that. What I'm telling. Let us suppose we have one device. You have to measure the pressure of your water. So if you will use the water in manometer for measuring the pressure, so you know the density of water is 1000 and you are using the manometer with water which also have the density 1000. Once you will measure the your pressure using manometer with water, what will happen? You have to actually, why high density? Means high density, let us generally use the mercury. So mercury have the density. Let me just use the pen, then you will understand very easily. So your mercury has the density this much, and water have rho of Hg H2O 1000, and you use manometer like the pipe type like this U2 manometer connected with water, connected with measuring pipe. If it is like that, if you are using water the same density, you have to need the extent of your pipe is very high because you have the same density. But when you will mercury, when you will use the mercury, so it is like the your density. If here you are measuring the H2O, the density of H2O, the density of mercury is very high. You can see here the 13.6 times more. Means if you will use the mercury, then you have to keep your the this height of your tube is less, because the 1000 kg per meter cube water have to rise the 13,600 kg per meter cube. Remember please, that is 13 times more weight your water will rise, lift in this manometer. So if you will have the high density, so your water will, let us suppose, increase the height up to here of you if you are using the mercury, because 13 times more. If you will use the water, it may be the here or more than that. So this is not feasible or not practical also. So that's why we use the high density. Here, the explanation also given, detailed solution. The liquid used in manometer should be high density so that the height of column, this column, can be reduced because the manometer are used for high pressure measurement. So it is important to make the column height in the practical limit. So hope you understand the whole statement I have already explained you. Question number 4. A water tank contains 1.5 meter deep water. The pressure exerted by water per meter length of the tank is option A is 8.29, option B 9.28, option C 11.03, option D 12.26. So now you please just try to write your answer in the chat box for question number 4. So please just try to write. In last 10 minutes, I'll show you the all questions of three set. And with concept also I will tell where it is required. Last 10 minutes. Before this, we have to go very manner way. You have to solve the question and you just write your answer. Okay, Gopika is telling C option 11.03. Fine. Other student, please also try to attempt. Okay. Hagen is telling option C. Fine. Okay. Monica is also telling C option. Fine. Okay, let us solve. So you have and water tank contains. You have water tank, 1.5 meter deep water. Okay. The pressure exerted by the water per meter length of the tank. Length means like that you have the tank. Like that you have the tank. And the length of tank is 1 meter. So like that you have tank. So you have to calculate and water you have the depth of is 1.5 meter. So the pressure exerted by water per meter length of the tank. But here it is not given at which location, whether at 1.5. At least in the question need to write the maximum pressure. So based on that, we can understand it is asking where is the maximum happening. Okay. So remember such type of typo mistakes. You have to consider yourself in the questions. So water tank contain this. So pressure exerted. Rho Z H and water you have 1000, 9.81. H is your 1.5. So after calculation, hope you will get option C. I'll just show you. Yes, option C you will get. Okay, here I think it is okay. The pressure force is calculating here. Why? So question is asking about pressure, not pressure force. Okay, maybe you have to correct this. So pressure force is Definitely this equation. Your pressure force is your pressure rho g h bar into area. So area is your h into L. L here it is given 1. So rho g area is h into L. So you have h square and h bar is your h by 2. So h square by 2. So you have to calculate here the pressure force exerted by water per unit length is given by. So now here you can write easily. Sorry. Okay, you have to correct the statement of the question. So this is your 1000. Omega is nothing but rho z it is written. So 1009.81, 1.5 is meter square by 2 is your this much. 11.03 kilonewton. Okay. So question number 5. The equation of streamline passing through the origin in a flow field U cos alpha, V sin alpha for a constant alpha is determined as equation of a streamline, not stream function. Equation of a streamline you have to calculate here when U is given cos alpha and V is given sin alpha. And alpha here is constant. So please, everyone solve. Okay, you need someone telling the kilonewton in the previous question. Okay, let me just see what was the mistake. Yeah, it's kilonewton, fine. Okay, okay. So please just try to solve the question. Next question, question number I think 5. Yes, question 5. The equation of a streamline. So first you have to understand the streamline equation. So based on equation, you have to solve this. Actually, the question 5, the equation of a streamline. Anyone, please just try to solve. Okay, C option is telling y is equal to x tan alpha. Again, y is equal to x tan alpha. Okay, I am expecting from other student also. Okay, Gopika is also telling C. Okay, let me just show you the answer. The equation of a streamline for these two component of the velocity u cos alpha and the sin alpha. So option C is correct, but how? So this is your equation of a streamline. This is not del. Sorry. So here you can put. So after that you can integrate both sides. After integration, what you will get? You will get this x sin alpha. This is sin equal to y cos c. Origin in the question is given y cos alpha. So from here you can write very easily y is equal to, because your question is given in terms of y, so you have to write in terms of y. So hope you understand. Next question, question 6. A uniform body 3 meter long, 2 meter wide, and 1 meter deep float in water. The depth of immersion is 0.6 meter, then the weight of the body. You have to apply here the Bernoulli concept, or not Bernoulli, Archimedes principle. So option is given, very close option. Here you can see 31.5. So you have to be precise with your calculation. After this question, I will show you the all questions of set 2 and another set also. So hope you are able to. Anyway, if you not, just I'll show you in the very few minutes the whole question. So if anyone not able to understand, then we can discuss in the next class also. No issue. Please try to solve this question number 6. Question number 6, please. You have another 2 minutes, then after I'll show you the answer. C, 35.3, okay? Kopika is telling option C, 35. That student, please also. Okay, I will show you the answer now. Okay. So yes, option C is correct. So how? You have the body of your dimension 3 to 1, all three dimension. That is your volume will be 6 meter cube. The volume of water displaced is equal to weight of body in kilonewton slash a specific weight of water in kilonewton meter cube. So if you will put here, now we also know that from your question, depth of immersion is equal to volume by cross-sectional area. So 0.6 volume is V because here represented, and 3 into 2. And after calculation, you will get 3.5. Okay, let me explain in another way once you will see the answer. So putting the value of V in equation 1, you will get this final answer. Okay. So what question actually? Let me just explain in another way. A uniform body of 3 meter long, 3 meter long, wide 2 meter, and deep 1 meter. If the depth of immersion is 0.6 meter, this depth of immersion, not all, only this 6 meter, 0.6. The immerse water up to that level, this 0.6, and the remaining above the water is 0.4. Then the weight of the body. So weight of the body is what? Weight of body is nothing but the weight of water displaced. So here weight of the body is how you will calculate because your density is not given. Okay, you have to calculate the weight of the body. Okay, fine. So weight of water displaced is equal to your weight of body. So weight of water displaced means what? If how much volume is in the your water? So only this much volume means 4 meter into 2 meter wide into 0.6 meter. So this is your volume. And what is weight? Weight you know already. Sorry. or unit weight. Let me just explain in another way. What is having like, okay, unit weight gamma is equal to weight divided by volume. So for calculation of weight, you have to gamma into volume. So gamma into volume. Here, the weight of water. So volume, you know already, volume is this much. 4 to 0.6, 4.8 meter cube. And gamma is rho into Z, 1000 G, 9.81. So now you can write here 4.8 into 9.81 into 1000. So this is your weight of water displaced. This is your weight of water displaced. So after calculation, so whether option B, C is coming right or not? Okay, a similar thing. Where we have did mistake, please. Anyone can find out? Oh, this is not 4, please. This is your 3. 3. This length is 3. 3.6. This will be your 3.6. 3.6. So, and this is your gamma. So here 3.6. So after calculation, you will get 35.3 kilonewton. So hope you understand. Nothing, very simple one. The weight of the body is equal to whatever will be the weight of the body, the whatever you will immerse in the water. That is, immerse is not depend on you. It is depend on your density of water and your density of this block. So it is immersing 0.6. So that portion only displays water, not all portion. That portion only displays. So that's why we have equated with the weight of water displays. So now you will get this. So now in very simple way, you all hope you all got it. Okay, finally, if you got it, you can say yes, please. So I'll move with the very fast with another questions. Please say yes. Anyone? Very important question. The conceptual question also. Okay, fine. So next question is your the two-dimensional flow field represented by phi 2xy minus x determine the value of the velocity v at point 22. So you have to calculate the velocity. So velocity is this u is equal to, so velocity means you have to calculate this one, u square plus v square. Not simple, you will calculate the velocity. U is equal to del phi by del x. Not simple. You have to calculate also v component, also w component. But here w is not given, so it is 0. Now, next one. Next question. In this steady flow, a compressible fluid through a pipe density, same question what we have already solved. So no need to the explanation. The imaginary line, okay, you the same question is the streamline. It is also the same question. The streamline is a we have discussed already. So no need pressure less than atmospheric pressure is known as suction pressure, vacuum pressure, negative gas pressure. All of them. This is the new question. Okay. Question number 12. For a perfect incompressible liquid, the flow for following the continuous stream. The total energy of a particle remain the same while the okay same Bernoulli principle we have already discussed. This set is now let us move with the next one. Question number one. Compressibility is the reciprocal of bulk density. You all know. Is the first question I think sir has to. The find equivalent head of mercury. So same question. Equivalent head of mercury of 10-meter head of the water. So at the place of the 10-meter head of the water. So remember please how you will incorporate these things. Because previous question was about in terms of head water, but here is a 10-meter head of water. So here you can see what we need to calculate the head of mercury in terms of 10-meter head of the water. So H value here it is given 10 and the mercury then specific gravity is given. Proper pulp is an example of pseudoplastic, Newtonian fluid, thixotropic, elastic fluid. So we have discussed in assignment 1 that is week 1 class very well. So you can follow please. Next question, similar question we have solved already. The tank contains 3-meter deep water. The same question, please. Next one here. Okay. The question 5, similar question. Question 5 also. Question 6. Yes, similar question. Here, the 4-meter wide and 2-meter deep. Instead of your initially was 3-meter, 2-meter, and 1-meter. You can easily solve. No issue. Two-dimensional flow. Similar question. You can see here very clearly. The question is repeating. So repetitive questions. So if you will solve all question, you are very easily solve all assignment question very easily. Similar question you know already we have solved in the first set. The similar question here definition of the streak line. In inert pressure is injected continuously from a point in an unsteady flow field. The locus of location of all trace particle in a in an instance of time represent means you have some dike here and color. You are putting color from here. So you can see this. The locus of location of the trace particle. So this locus is known as your, I think this is your streak line or path line. You please confirm. Confirm please. Very important. It is streak line. Okay, fine. Not path. Streamline already we have solved. Question 11. The depth of center of pressure. This is new question. Base we immersed vertically in the water. Its base at the free surface. Means like this. Base at the free surface. You have to calculate this is your center and this is your center of pressure. So you have to calculate the center of pressure, HC. So how we will calculate the very standard formula? This one, HP or SC you can say. HC is a dot HPI file, right? Then you can connect very well. So HC means this value is SC. So SC is your H by 3 from the base, H by 3. And the moment of inertia about the your center BH cube by 36 after calculation and AHC. A is half B into H and HC is H by 3. So after calculation you will get H by 2. Next question, very important. For a particle, okay, For a perfect incompressible liquid flowing in a continuous stream, the same question, I think it is Bernoulli equation. We have already seen. Yes. Okay, so hope you all enjoyed the session. So this is about today. So we'll meet with the new questions next Sunday, the same time, 5 to 7. So you all are able to access the this material as well as YouTube, whatever I'll upload this video. Are you able to access? If anyone not, please just write here not, then I'll show you. If anyone able to access, no need to write. Okay, I think everyone aware about it. Okay, fine. Then we'll meet in the next class. So now you can leave the class, please. So if anyone have any doubt, you can also ask. As we have seen, the question is repeating from year by year in the assignment. So if you will solve all the question, definitely. So thank you. Thank you, Susan. You are able to solve all the assignment question. No issue. Okay, please everyone can leave the class.